gravity. So to put it simply, in terms from a flat earther, no one is disputing that things fall down. The measurement of the rate at which they fall is an empirical measurement of kinematics. We all understand the difference between kinematics and dynamics, and measurements of kinematics are model independent, right? They don't prove either model. We would dispute the cause of gravity, or rather big G. If we were to break it down, little g is kinematics, big G is dynamics. We're only disputing the dynamics. We would dispute the cause of big G as mass attracting mass. We would replace that with an electrostatic downward bias, right? Where the charge of Earth produces the downward gradient, gives it the direction of down, and then buoyancy, density, and viscosity sort the rest of it out. Mathematically, if we were to describe the rate at which things fall, we could do so by calling it the acceleration downward, little a, and you could derive it just with the equation 2h over t squared, or 2 times the height at which an object is dropped over the time it takes to fall squared. And this is, of course, a simplified version of the equation with velocity at 0. So d equals v0t plus 1/2 at squared. And we can solve that with multiple examples to get 9.8 meters per second squared. Right, so in a real-world example, if an object is dropped from 10 meters and takes 1.43 seconds to fall, you can solve for a using the same equation. You could say a equals 2 times 10 over 1.43 squared, or a equals 20 over 2.0449, or 9.78 meters per second. Right? And that's how you get the empirical kinematic measurement of the rate at which things fall. No mass attracting mass or Newtonian gravitation required.